Hey people, this video is on synthetic division and remainder theorem, and this is just a spin-off of when we talked about long division. So we just recently talked about long division. Now we're going to talk about something called synthetic division, and I apologize in advance. I'm really sorry. I have a bit of a cold, so sorry that you have to hear this on the video. So what is synthetic division? It's one of two methods that we can use to divide polynomials, the other one being long division. But it's a bit of a shortcut as you're only dealing with coefficients. So now we don't have to deal with the variables. We don't have to deal with like the x cubes, the x squareds. However, we can only use synthetic division if we are dividing by a linear binomial of the form x minus a. Okay, so if you take a look at our first example here, this is synthetic division. If you notice right here, the division that we're dividing by, this is a linear binomial, so it's to a degree of 1. There's two terms only, and it is of the format x minus a, where a is just 3. Okay, how do you do synthetic division? This is what you need to do. For starters, you're going to do a long division symbol, but it's going to be upside down instead of right side up. Then you are going to place the coefficients of the dividend on the top of this long division bar. Again, only the coefficients, and it has to be standard form. So our highest degree is x to the power of 3. The coefficient of that is 3. It's just a coincidence that they're the same. After x to the power of 3, we've got x to the power of 2. The coefficient of that is negative 5. Leave a little bit of space and write negative 5. Do the same thing with the first degree term. We're going to leave a little bit of space and put negative 7. And then lastly, the constant term is negative 1. Leave a little bit of space and write negative 1. Now, when we do our division, we're going to put over here, we're going to put the a value. So here, again, the a value is 3. We're going to put the 3 here. So this is the a value, okay? So now, for long division, our first step is to always bring down this first coefficient. Always, no matter what, okay? So we bring down this first coefficient. Then what we do is we take this coefficient and we multiply this by the a. So I'm going to take 3, I'm going to multiply it by the a value, which is 3. So I'm going to do 3 times 3, which is 9. And then I'm going to put it underneath the next term. And then I'm going to add these two terms together. So I'm going to do negative 5 plus 9. And sorry, when I say terms, I meant like just coefficients. So negative 5 plus 9 is 4. I bring that down, and then I multiply that by a again. So I just keep doing this over and over again. So 4 times 3 is positive 12. I add the negative 7 and the 12 together right here. Negative 7 plus 12 is 5. I'm going to take that, multiply that by a, which is 15. Then I'm going to add this negative 1 and 15 together, and negative 1 plus 15 is going to be 14. So a couple things that are different about synthetic division. First of all, we don't have any variables. Second of all, when we're doing each step repeatedly, like we did with our long division, this time we're adding it, we're not subtracting it. And the reason why is because we changed to the opposite sign right here already. So what does all this information tell us? Well, for starters, it tells us that this term right here is going to be your remainder. And then we work our way backwards. So this is going to be the 0th degree term. This is going to be the 1st degree term. And this right here is going to be the 2nd degree term. So what does that tell us? This tells us that our quotient is going to be equal to 3, because this is the 2nd degree term, it's going to be equal to 3x squared. Our 1st degree term is going to be 4x, and it's positive 4, so we write plus 4x. And then our 0th degree term, or pretty much our constant term, is going to be 5, so positive 5. And then our remainder, we just figured out, was 14. So synthetic division is going to feel a little bit weird at first, but it's actually much simpler than long division is. It's a lot easier than long division is. Okay, so what does this mean? This means that the answer to this right here, when I do this division, it's going to be equal to 3x squared plus 4x plus 5. That's what I got right here. That's the quotient I got right here, with a remainder of 14 out of what I'm dividing by, which is x minus 3, just like we did with our long division, okay? I just want to say one last thing, though, about this problem right here, and that is that this expression right here, this dividend, which is what we are going to be dividing, is equal to what we divided by, which is our divisor, multiplied by the quotient with a remainder of 14 right here. So if I were to expand this whole thing out right here and then add 14 to it at the end, I would get the dividend to begin with, okay? If you want to pause and double check to make sure that works, I would strongly suggest you do that just to be 100% sure that you really fully understand this concept, okay? Okay, now in example 2, if you notice, I'm giving you a function that is identical to the dividend in example number 1, okay? And it's asking you to find f of 3, which was the a value that we did in example number 1. Let's go ahead and plug this in and see what we get. So every time I see an x, I'm going to replace it with 3. So I end up getting 3. 3 to the power of 3 is 27. So I get 3 times 27 minus 5 times 3 to the power of 2 is 9 minus 7 times 3 minus 1. Well, 3 times 27 is 81. Negative 5 times 9 is negative 45. Negative 7 times 3 is minus 21. And then copy down the minus 1. Let's do this calculation, see what we get. Well, I'll just type in 81 minus 45 minus 21 minus 1. And I end up getting 14. Interesting. Where have we seen 14 in the previous problem right here? Is a very interesting question. Let's skip that for now and go on to the next one. All right, in example number 3, we're asked to divide the Cortic polynomial. So just a quick note that Cortic means it's 4th degree, just like quadratic means second degree, and linear means 1st degree, and cubic means 3rd degree. Cortic means 4th degree. But I want you to notice this expression right here. Notice how the exponent goes from 4 to 3 to 2, and then to the constant. There's no linear term here. So we actually have to rewrite this with a linear term. So we're going to say 2x to the power of 4 minus 3x cubed minus 12x squared. Now, because there is no linear term, we're going to say plus 0x and then plus 8. And we have to put the 0x here because it has to be in descending order. So let's go ahead and set up our long division right here. So right here, we're going to say that we have 2. Our first coefficient is 2, then negative 3, then negative 12, then 0, and then 8, okay? And because we are dividing by x plus 4 right here, our a value here is negative 4. Because the divisor is in the format x minus a, the a value has to be negative 4 to get x plus 4, okay? All right, so remember, we always start by bringing down this 2 first. So I bring down the 2, and then I start to do my multiplication. So I do 2 times negative 4 right here, which is negative 8. Then I add these two numbers together, okay, and I end up getting negative 11. Then I take that negative 11, multiply that by negative 4, and I end up getting positive 44. Then I add these two numbers together. So negative 12 plus 44 would give me 32. Take the 32, multiply that by negative 4 right here, and I would end up getting negative 128. Add these two terms together right here, 0 and negative 128 would give me negative 128. Multiply negative 128 by negative 4, and you end up getting positive 512. Add the 8 with the 512 right here, and I would end up getting 520. So just a reminder, this right here is the remainder. This is the 0th degree term, 1st degree term, 2nd degree term, third degree term. We're just going to work backwards. So what does this tell us? This tells us that our quotient is going to be 2x to the power of 3 minus 11x squared plus 32x minus 128, and that our remainder is going to be 520. But also, just a reminder that we can also just simply write this out as, we could take the dividend, which is 2x to the power of 4 minus 3x cubed minus 12x squared plus 8. And we could say that that is equal to our divisor, which is x plus 4, times our quotient, which is 2x cubed minus 11x squared plus 32x minus 128. But we also have to add on our remainder, so plus 520. And then again, if I were to expand this whole thing out, get an expression, add 520 to it at the end, I would end up getting this dividend right here. Now, if you notice right here, our next example is asking us to take a look at a function, g of x equals this right here, which is identical to what our dividend was up here. And it's also asking us to find g of -4, which is identical to the a value that we used right here. So let's go ahead and do that and see what we get. So every time I see an x, I'm just going to replace it with -4. So right here, I'm going to say that this is 2 times. Now, -4 to the power of 4 means -4 multiplied by itself 4 times. I end up getting a positive value. I get 256. Then I've got -3 times -4 to the power of 3. So this ends up becoming times -64. Okay, so I'm just evaluating my powers right now. Minus 12 times -4 squared, which is positive 16, plus 8. Well, 2 times 256 is 512. -3 times -64 is positive 192. -12 times 16 is -192. And as I'm doing this, I do expect you to do these calculations in your calculator. So if you need to pause to double check, please do so, because I want you to be actively participating in this lesson, okay? And then plus 8 right here, and notice the 192 and the -192 cancel each other out. If I add 512 and 8 together, I get 520, which is a number that I've seen before, 520, 520. 14 right here, 14. So if you notice right here, if you plug in whatever the a value is, it tells you the remainder right away. So that's what the remainder theorem says. When a polynomial f of x is divided by f minus a, the remainder is equal to f of a. So anytime you want to find the remainder, you just plug in f of a. You just identify what f of a is, just like right here. We identified what g of -4 is. Okay, so this one's a little bit trickier. So for starters, let's actually find the remainder. But to find the remainder, we need to identify what the a value is right here. And this is the tricky piece of this right here. So if you notice in the remainder theorem, or in even with synthetic division up here, we said that the binomial has to be in the form x minus a. But in this one right here, it is of the form 2x minus 3, but it has to be 1x minus a. So what we're going to do here is we're just going to set the divisor equal to 0 to identify the a value. So here, I'm just going to say 2x minus 3 equals 0, add the 3, divide by 2, and I get 3 over 2. So that means that the a value is equal to 3 over 2. So let's find the remainder to start off with. So our remainder here is going to be equal to 4 times 3 over 2 cubed minus 11 times 3 over 2 minus 9. And I really don't want to get bogged down on calculations right now, because that's not really the point of what I want to talk about in this example. So I'm just going to go straight to my calculator and type that in. And when I do that, you can see right here that my answer is going to be negative 12. So that tells us our remainder is negative 12. So let's go ahead and do our long division. But remember, if our expression right here is 4x cubed minus 11x minus 9, there is a 0x squared here that we cannot ignore. So let's go ahead and set it up. So I'm going to say here that I have, my coefficients are going to be 4, 0, negative 11, negative 9. And my a value here is going to be 3 over 2. Okay, so pay really close attention to this one because something weird is about to happen. Just like we did before, we bring down the 4, okay? And then I multiply this 4 by this 3 over 2. And when I multiply 4 by 3 over 2, I end up getting 6. And now I'm going to add the 0 and the 6 together, and 0 and 6, when I add them together, gives me 6. Next, I'm going to multiply 6 by 3 over 2, and that gives me 9. Then I'm going to add the negative 11 and 9 together, and that gives me negative 2. So now I'm going to multiply negative 2 by 3 over 2, and that gives me negative 3. Add negative 9 and negative 3 together, and I end up getting negative 12, which is the remainder that we found right here. You might be wondering, well, what's the point of finding the remainder if we had to do synthetic division to begin with? And we'll talk about that eventually, I promise, okay? All right, so here's our remainder right here. This is our 0 degree term, or constant, first degree term, and our second degree term. Now I want you to pay very close attention to this next thing that I'm going to show you. So pretty much what ended up happening here is we end up saying that if I take 4x cubed minus 11x minus 9, to get that answer, I'm going to take what I divided by, which was technically x minus 3 over 2, and I didn't technically divide by 2x minus 3. It was x minus 3 over 2, and I ended up getting this right here, which would end up becoming 4x squared plus 6x minus 2. But the problem is right here is that the question specifically asked me to divide by 2x minus 3. So if you take a look at this right here, I want this x minus 3 over 2 to eventually look like this 2x minus 3. So I'm actually going to take this expression right here, and I'm going to factor out a common factor, which is 2. So I'm going to take out a 2, and this ends up becoming 2x squared plus 3x right here. That becomes 3x minus 1. And then, because it's multiplication, I can rearrange the order of this. So I'm actually going to put the 2 in front right here. So this ends up becoming 2 times x minus 3 over 2 times this 2x squared plus 3x minus 1 that I have left over in here. Well, now I can distribute the 2 through, and I end up getting 2x minus 3 as my first factor, times this 2x squared plus 3x minus 1. But I apologize because I forgot something really, really, really important, which is our remainder of negative 12. So there should be a minus 12 here, minus 12 here, minus 12 here, minus 12 here. Notice, however, that in this whole entire process, the minus 12 was unaffected. Notice here that the remainder was also negative 12. So it only affects this piece right here. And if I'm going to write it as 2x minus 3 instead of x minus 3 over 2, then everything inside of here has to be cut in half. It's not a coincidence that this is 3 halves. And we'll do more practice with this right now so you can see it kind of getting pulled all together in this last example. So in this next example, it tells us that 4x plus 5 is one factor of this entire expression right here. And then it says to factor the entire expression. Let's talk about this for a second. If it says that 4x plus 5 is a factor, it means that this is evenly divisible by 4x plus 5. So I'm going to actually want to divide 4x plus 5 into this expression here. I want to use synthetic division just because it's easier, but I have to rewrite this in the format x minus a. Right here, 4x plus 5 equals 0. Subtract the 5 and then divide by 4. My a value here is negative 5 over 4. The goal is for you to be able to go straight to that. So really what we're doing here is we are going to do our our synthetic division of 8x cubed plus 62x squared plus 37x minus 35 with negative 5 over 4 as our a value. So same thing we always do, bring down the 8, multiply it by negative 5 over 4 right here, and I end up getting negative 10. Add the 62 and the negative 10 together, you end up getting 52. 52 times negative 5 over 4 right here, negative 65. We need to add that negative 65 to this 37 here. You end up getting negative 28. Now multiply that negative 28 by negative 5 over 4 right here, and we end up getting positive 35. And then here, when I add these two together, I actually end up getting a remainder of 0. Well, what does that mean if I have a remainder of 0? We could say that this 8x cubed plus 62x squared plus 37x minus 35 is going to be equal to this x plus 5 over 4 multiplied by 8x squared plus 52x minus 28 with a remainder of 0. So that means I don't need a 0 here, which means that it is this x plus 5 over 4 was an even factor, which means 4x plus 5 will also be an even factor. So how do I get that 4x plus 5? I take this expression right here and I factor out what's in common, which is a 4. Not a coincidence that there's a 4 here and we're factoring out a 4. So when I factor that out, I get 2x squared plus 13x minus 7. So then I can bring the 4 through and distribute it through to everybody inside of here. So this x plus 5 over 4 becomes 4x plus 5 times this 2x squared plus 13x minus 7. Now, I don't expect you to do this work every single time. If you see this expression right here and you see that there's a denominator of 4 in the a value, just divide each one of these terms by 4 when you write it as 4x plus 5 times this stuff right here. Okay? And then lastly, it says to factor the entire expression. So I'm going to copy down the 4x plus 5 because that I can't factor that any further. And then I can actually factor this expression right here as 2x with x. I'll try the 7 here and the 1 here. This gives me 1x. This gives me 14x. I'm trying to get 13x, which is totally possible. So I end up getting a positive 7 here, a minus 1 here, and this is my factored expression. Let me know if you have any questions. Otherwise, I'll see you in class. Bye.